Okay, good morning everyone. Today we are going to do sum 12 by principle of mathematical induction. Okay, sum is a plus ar plus ar square plus up to plus a r raised to n minus 1 is equals to a in the bracket r raised to n minus 1 upon r minus 1. We have to prove this sum by principle of mathematical induction. So first we take given statement as P n, and first we prove the given statement is true for n is equals to 1. So for n is equals to 1, we can take left hand side. So left hand side is a, otherwise in last term of left hand side you can put n is equals to 1. So 1 minus 1, 0. R raised to 0. If any number has power 0, then answer is 1. So here a. And right hand side, in right hand side we can take as n 1. So a. R raised to 1, that means r minus 1 upon r minus 1. So a. So left hand side is equals to right hand side. So we can say that P of 1 is true. Okay. Now we assume that P of k is true. We assume that P of k is true. So we can write down statement P of k. That means statement Pn, but we can replace n by k. So a plus ar plus ar square plus up to plus a r raised to a minus 1 is equals to a r raised to k minus 1 upon r minus 1. Okay, we assume that given statement is true for any natural number k. Okay, now to prove P of k plus 1 is true, now we have to prove that P of k plus 1 is true. So to prove P of k plus 1 is true, we can take left hand side. So in left hand side, first we have to write down left hand side of P of k. So I can write and then we can write one step more, and this step is last step of P of k, but we can write k plus 1. So here k, we can write k plus 1 instead of k. So k plus 1 minus 1. Okay, again repeat. Left hand side of pk, for left hand side of pk we can write down left hand side of pk, and then one step is more. In this step we can write k plus 1 instead of k. That means k ની જગ્યાએ k plus 1 replace કરવાનો. Okay, so now for these steps we can replace value from pk. A r raised to k minus 1 upon r minus 1. And this step is a r raised to plus 1 minus. So, okay. Now we have to simplify this addition. And if we get answer, what answer? In given statement, right hand side of given statement, we get k plus 1 instead of n. That means if we get a r raised to k plus 1 minus 1 upon r minus 1, then we can say LHS is equals to RHS. So to simplify these two terms, we want to get a r raised to k plus 1 minus 1 upon r minus 1. Okay. First, we can take a as common. So we have here r raised to k minus 1 upon r minus 1 plus r raised to k. Now we take r minus 1 as LCM. So r raised to k minus 1 plus r raised to k into r minus 1. We can take r minus 1 as LCM. So a r raised to k minus 1 plus r raised to k into r. Base are same, then addition of power. So r raised to, here power is 1. So r raised to k plus 1 minus r raised to k upon r minus 1. So r raised to k and r raised to k is cut. So here a r raised to k plus 1 minus 1. And we want this a r raised to k plus 1 minus 1 upon r minus 1. So we can say that LHS is equals to RHS. And therefore P of k is true, implies P of k plus 1 is true. That means we take P of k is true, and by using this we prove P of k plus 1 is true. And therefore by PMI, principle of mathematical induction, given statement Pn is true for every natural number. Okay. Now we are going to do question number 13. Statement is 1 plus 3 upon 1. 1 plus 5 by 4. 1 plus 7 by 9. Plus up to plus 1 plus 2n plus 1 upon n square is equals to n plus 1 whole square. Okay. We have to prove this sum by principle of mathematical induction. So first we take given statement as Pn for every natural number n. Okay, first we prove P of n is true. P of 1 is true. So for n is equals to 1. Left hand side is equals to 1 plus 3 is equals to 4. Right hand side we can replace n by 1. So 1 plus 1 whole square. So 2 whole square. So 4. That means LHS is equals to RHS. And therefore we can say P of 1 is true. Okay. Now we assume that P of K is true. So we write statement P of K, that means exactly statement Pn, but we write K instead of N. That means N is replaced by K. So 1 plus 3 by N, 1 plus 5 by 4, 1 plus 7 by 9, plus up to plus 1 plus 2k plus 1 upon k square is equals to k plus 1 whole square for all k belongs to natural number. Okay, we assume that this statement is true for any natural number k. Now to prove P of k plus 1 is true, we take left side. Okay, so in left side first we have to write down left side of P of k. And then first we have to write down left side of P of k, and then we have to add one step more, and this step is last step of P of k, but we replace k by k plus 1. So next step is 2. K is replaced by k plus 1. So k plus 1 plus 1 upon k is replaced by k plus 1. Okay, again repeat. To write left hand side of P of k plus 1, first we have to write left side of pk, left side of pk, and then we have to add one more step, and this step is written how? Last step of pk is in last step of pk, k is replaced by k plus 1. Okay, now we can put the value of left hand side of pk, and answer is k plus 1 whole square. We assume that P of k is true, and therefore the value of this step is k plus 1 whole square. Okay, now plus 1 plus here 2 is multiplied with this bracket, so 2k plus 2 plus 1, so here 2k plus 3 upon k plus 1 whole square. Okay, now to simplify these two steps, if we get in right side of P of n is replaced by k plus 1, that means k plus 1 plus 1 whole square. That means if we get k plus 2 whole square, okay, we get k plus 2 whole square, then we can say that LHS is equals to RHS. Again repeat these two steps is simplify, and then if we get in right side of Pn n is replaced by k plus 1. That means n. So k plus 1 whole square. So k plus 2 whole square. That means if we get, by simplifying these two steps, k plus 2 whole square, then we can say for p of k plus 1, left hand side is equals to right hand side. Okay. K plus 1 whole square. Okay. Now we can take k plus 1 whole square as LCM. So k plus 1 whole square upon k plus 1 whole square. So k plus 1 whole square in the bracket. K plus 1 whole square expansion. So a plus b whole square. So a square plus 2ab plus b square. So k square plus 2k plus 1 plus 2k plus 3. So here and here k square 2k plus 2k like term. So 4k plus 1 plus 3 4 upon k plus 1 whole square. So here we have k square plus 4k plus 4 is a perfect square of k plus 2 whole square, and we want k plus 2 whole square. So we can write LHS is equals to RHS, and therefore last two statements we are written as P of k is true, implies P of k plus 1 is true, and therefore by PMI, that means principle of mathematical induction, given statement Pn is true for all natural number. Okay. Now we are going to do question number 14. This is given statement, and we have to prove this statement for every natural number. Okay. So first we prove P of 1 is true. Here this statement is P of n for all natural number. Okay. For n is equals to 1, left hand side. So 1 plus 1. So 2. And right hand side, to get right hand side we replace n by 1. So 1 plus 1. So answer is 2. So we can say LHS is equals to RHS, and therefore P of 1 is true. Okay. Now we assume that P of k is true. That means this statement is true for any natural number k, and therefore we can write P of k. Actually we have to write down statement Pn, but replace n by k. So k plus 1 for all k belongs to n. And now to prove p of k plus 1 is true, we take left hand side. Okay, again repeat. To write down left hand side of p of k plus 1, first we have to write down left hand side of p of k, statement p of k. So I can write okay, and then we have to add one more step, and this step is written by in last step of p of k. We can replace k by k plus 1. So another step is 1 upon k is replaced by k plus 1. Okay. Now we replace the value of this step from p of k, and value of this step is k plus 1. So here I can write k plus 1 plus this step is as it is. So 1 plus 1 upon k plus 1. And after solving these two steps, if we get what we get in right hand side of p of n is replaced by k plus 1, that means k plus 1 plus 1, so k plus 2. So solving these two steps, if we get k plus 2, then we can say for p of k plus 1, left hand side is equals to right hand side. Okay. Now this k plus 1 as it is. In this bracket we can take k plus 1 as LCM. So here k plus 1 plus 1. So k plus 1 k plus 2 upon k plus 1. And we also want k plus 2, and here k plus 2. So we can write left hand side is equals to right hand side. That means p of k plus 1 is true, and therefore we can say p of k is true implies p of k plus 1 is true. That means we take statement is true for any k, and using this we prove statement is true for k plus 1, and therefore by PMI, that is principle of mathematical induction, given statement Pm is true for every natural number. Okay, I can send you all this sum by PDF, and you have to write down in your notebook. Okay.